Hello everyone, you're welcome to Mr. Life Changers class. In this video, I'm going to be showing you different questions. We're going to be solving questions and answers on electric current, Ohm's law, cells, and all of that related to that. That would help you, grasp some important information. Let's start with the first one here. It says Ohm's law states that the current flowing through a conductor is, we have different options here, but the answer to this question is B. It is directly proportional to the potential difference across it, provided that temperature is constant. So according to Ohm's law, I is proportional to V, which means that V is equal to IR. That's very important for you to note. Okay, the second question here says that a resistor of 15 ohms is connected across a 9 volt battery. What is the current flowing through it? Okay, so according to this is a simple Ohm's law question. According to Ohm's law, V equal to IR. So that means the current, if you divide both sides by R, the current is going to be V over R. So the V here is 9 volts. The R here is 15 ohms, and that's going to give us 0.6 amperes. So the answer to this question is B. Quite easy, right? Now, in this case here, it says 3 resistors of 4 ohms, 6 ohms, and 10 ohms are connected in series. What is the total resistance in the combination? Whenever you see series combination, the total resistance is R1 plus R2 plus R3. That means you add the 3 of them. So this is going to be 4 plus 6 plus 10. And that is going to be 20 ohms. So that makes D the answer to the question. Okay? Now that leads us to number 4. It says in a series circuit, resistors of 3 ohms, 7 ohms, and 10 ohms are connected to a 40 volt supply. Okay? The current flowing through the 7 ohm resistor is, now I want to represent this in a diagram. In this diagram we have 3 ohms, and the next one we have 7 ohms, and the next one we have 10 ohms, and the 3 of them are connected in series, connected to a 40 volt resistor, and you can have an ammeter here to measure the current. Okay, so but I want to say something here, that as long as they are connected in series, the same current flows through them. This is the current supplied by the cell, so this is in series with this, in series with it. So the current flowing through this is the same as the current flowing through this, and the same as the current flowing through this, which is the same as the current supplied by the battery. Okay, so in order to find this current, you can apply Ohm's law. I is equal to V over R. Now to find the R is the total resistance, which is 3 plus 7 plus 10, because they are in series, and that is going to be 20 ohms. So that means your I is going to be V, which is the voltage, 40 volts, divided by R, which is 20 ohms as we just got. So the answer is 2 amperes. Quite easy, right? This is quite easy. Quite easy. Now, I want to add this. This is just an addition, to help some of you. If you are asked to find the voltage across each of them, because they are in series, they have the same current across them, but different voltage is, they have the same current passing through them, but different voltage is applied across them. That means this is V1, this is V2, V3. The voltage across this is V1, the voltage across this is V2, the voltage across this is V3. That is very important. Okay, so if I want to find each voltage, very easy. V1 is going to be IR1, the same current. V2 is going to be IR2, V3 is going to be IR3. This is how you treat a series connection. So the voltage across this one here is the current is 2, so 2 times 3, which is 6. This one is 2 times 7, which is 14. And this one is 2 times 10, which is 20. How you know your answer is correct is that when you add these 3 voltages, you are going to get the total voltage, which is 40 volts. You see? That's quite easy, isn't it? Quite very, very, very easy. Okay, so that now leads us to the next question here. It says 2 resistors of 6 ohms and 12 ohms are connected in parallel. Their combined resistance is, now this is how we represent it in a diagram, parallel connection. when two resistors are in parallel, this is how we write it. This is 6 ohms, this is 12 ohms. Now, but I prefer to use a formula whenever 2 ohms are connected in parallel. It helps you get your answer fast, especially if you're in an objective setting. It is the product, total resistance is the product of the resistors all over the sum of the resistors. So that means 6 times 12 over 6 plus 12. That is 72 over 6 plus 12 is 18, which is equal to 4. So the answer is 4 ohms. Now, but that does not mean you cannot apply this. 1 over R equals 1 over R1 plus 1 over R2. You can apply this if you want, which means 1 over R is equal to 1 over 6 plus 1 over 12. The LCM is 12. 12 divided 6 is 2. 2 times 1 is 2. Plus 12 divided 12 is 1. 1 times 1 is 1. So we are going to have 1 over R is equal to 3 over 12. So that means R is equal to 12 over 3, which is equal to 4 ohms. So the total resistance is 4 ohms. Very, very, very important. The same answer we got here. But you see, do what works for you. Now, this one, number 6, says, in a parallel circuit, the voltage across each branch is, the answer is that it is the same for all branches. Initially, I tried to explain how when resistors are connected in series, the same current flows through them, but different potential differences applied. But that's not the same thing for parallel connection. If I have 3 resistors in parallel, for example, let me say I have this. These are 3 resistors connected. A voltage is connected across them. This is V. This is R1. This is R2. This is R3. The same voltage here is the same voltage here, the same voltage here, the same voltage. That means voltage is the same, but current is not the same. The current here can be I1, the current here can be I2, the current here can be I3, and the total current is actually I1 plus I2 plus I3. So that means for resistors in parallel, different current passes through them, but the same voltage is applied across them. A very important concept that you should always remember. Now we have the 7th one here. It says a 4 ohm resistor is connected in series with a parallel combination of a 6 ohm and a 12 ohm. The total resistance in the circuit is very easy. If I should represent this in a diagram, this is 4 ohms. It is in series with a parallel combination of a 6 ohm and a 12 ohm. Okay, this is exactly what we have here. Okay, so if I want to find the total resistance, very, very easy. If you use the formula I taught you, this is in series with this parallel combination. So I'm going to say 4 plus, this parallel combination is 6 times 12 over 6 plus 12. So that's going to be 4 plus 6 times 12 is 72 over 18. That's going to be 4 plus 4, which is equal to 8 ohms. You see? Very fast. And your life changes. So this is 8 ohms as the answer. Okay, so that leads us to the next one. It says a 12 volts battery is connected to a circuit where a 2 ohm resistor is in series with a parallel combination of 2 8 ohm resistor. The total current drawn from the battery is, so first of all, a 2 ohm resistor is in series with a parallel combination of 2 8 ohm resistors. That's it. This is the diagram. And both of them are connected to a 12 volt battery. This is a 12 volt battery. If you like, you can put ammeter here to represent the current that flows through it. Now, I am asked to find, the question here says, the total current drawn from the battery is, now the formula for total current is simply V over R. That means voltage over resistance. Always note that, okay, according to Ohm's law. Now, but we can't use this formula directly since we have a combination of resistors. I should start by finding the total resistance, which is going to be 2 plus, this is going to be 8 times 8 over 8 plus 8. So that's going to be 2 plus, this is 64 over 16. That is 2 plus 4, which is equal to 6 ohms. So the total resistance is 6 ohms. Now the voltage V is 12 divided by the total resistance is 6, so that is going to be 2 amperes. So the current flowing through this circuit is 2 amperes. Very easy. Very easy. Okay, but what if I am asked to find the voltage across the 2 ohms and the voltage across the 8 ohms? I just want to add this, just to help you here. In this case, it means that the voltage across this, I can call it V1, and the voltage across this parallel combination, I can call this V2. Okay, that's important. To find V1 is very easy. I gave you a formula. V1 is equal to IR1, and so this will be, the current is 2, then your R1, the R here is 2 ohms, that makes it 4 volts. Now the V2, the second voltage, is going to be IR2 based on the formula, okay? And the current is 2, but R2 is the combination of this, because these two now can be combined to be 1. So the combination of this is, we already got here to be 4 volts, this 4 volts. So I'm going to say 2 times 4, and that is going to be 8 volts. You can confirm if your answers are correct. 4 plus 8 is 12 volts, which is exactly what we have here. Okay, that's by the way, just to help you out. And now the next one says the EMF of a cell is best defined as, the answer to this question is B, the energy per unit charge supplied to a circuit by the cell, including energy used internally. But generally, if I should give you a textbook definition, EMF is, the full meaning is electromotive force, okay? And it is the driving force, the force that drives electrons, that drives current through the circuit. Are you with me? Or you can, yes, that drives current through the circuit. Another way you can define EMF, these are different ways, one of them is going to surface. Another way you can define EMF is that it is the potential difference across the cell when it is not supplying current. That's it. The potential difference across the cell when it is not supplying current. So any of these can be used for the definition for EMF. Now I have one more question here. It says a cell of EMF 6 volts has an internal resistance of 0.5 ohms when it delivers a current of 2 amperes. The terminal voltage is, now I want you to know something, that the current drawn from a battery is given as E, the EMF, all over R plus R. The big R here stands for the external resistor, or what we call the load resistance, the load resistor, okay? While the small r here is the internal resistance, which is exactly what we have here. So if we should substitute value here, I is 2, your E is 6 volts based on the question here, then your R is, we don't know what it is, it's not given here, and your small r is 0.5. If we cross multiply, we are going to have r plus 0.5 is equal to 6 over 2. So r plus 0.5 is equal to 6 over 2 is 3. So that means R is going to be 3 minus 0.5, which is equal to 2.5 ohms. So your resistance is 2.5 ohms. That is very important for you to note, okay? Now, you're going to wonder, why am I finding the resistance? It's because of what we are asked to find, the terminal voltage. Because the formula, the terminal voltage is equal to I times big R, the current times the terminal voltage. And so the current the current times the external resistor, the current times the external resistor. So the current I is equal to 2 amperes. The external resistance, we just got it to be 2.5 ohms, and that is going to give us 5 volts. So that makes C the answer. 5 volts the answer. Okay, I hope this makes sense. Now, but I want to say something here. From this formula here, I equal to E over R plus R. If I cross multiply, I'm going to have E to be equal to I into big R plus small r. And if you open it, you're going to have I big R plus I small r. This I big R here is what we call terminal voltage. This I small r here is what we call lost voltage V. The capital V here is terminal voltage, and the small v here we call it lost voltage. Very, 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 very important. Okay, very important. Now, and so that means you can say that the EMF of a cell is big V plus small v. That's in case, questions like that comes up. So I have 30 questions here, but this stops here. So watch out for the next one. I remain Mr. Life Changer. You can always check my channels for videos like this that is going to help you maths, physics, chemistry, and the likes. Thank you very much. Have a nice day. See you in my next video.